Hello everyone, welcome you all. So today we are going to start one new topic and the name of the topic is breadth first search. So this breadth first search always comes in artificial intelligence, that is AI, and in AI we are having different algorithms to search the solution of the given problem, and out of those algorithms today we are going to learn BFS, that is breadth first search. Now what is exactly breadth first search? So guys, breadth first search. So in artificial intelligence, there are two types of algorithm. One is there are two types of search, we can say that. One is uninformed search and the second one is informed search. In informed search, we are having knowledge about whole domain. What will come after this node? What is the cost of this path? Each and everything will be known in informed search. But in case of uninformed search, we don't have full knowledge about the domain, right? So because of that, we cannot say that after a particular node, which node we need to visit. Okay, so that's why it is called as uninformed search. So breadth first search is also known as it is complete. Why it is complete? Because guys, yes, it is uninformed search, but this algorithm guarantees the solution. That means there is guarantee of the solution using this algorithm. So if you are having any problem and you want to find the solution of the problem, yes, if you are using breadth first search, yes, it is possible because there is a guarantee of the solution using this algorithm. That's why this algorithm is known as complete. Now what is the meaning of optimal? So students, optimal means what? It will provide the solution in very minimum cost. Yes, cost will be very minimum. Make sure that whenever if you are calculating the solution, cost will be very minimum. So if your cost is minimum, that's why it is called as optimal solution. Also one more thing, this breadth first search follows the concept of one data structure, that is yes, perfect, Q. And Q always follows the concept of FIFO. What is FIFO? First in, first out. What is FIFO, students? First in, first out. Okay. So in a queue, we are having one entry and one exit. So this entry way is known as something tail, and this is what? Head. So tail and head. So if you want to insert the node in the queue, it is always possible from the tail, and if you want to remove the node, yes, it is only possible from the head. Okay, so this is all about queue. So all these points, whether it is uninformed search, it is complete, it is optimal, it follows the concept of queue. That is what breadth first search. Now let's understand the breadth first search using one example. Okay, so students, let's have one example, and this example, yes, we can apply this breadth first search on graph or on a tree. So yes, we have taken the example of tree. So in this particular tree, we are having one parent node. This parent node is having three child node, that is B, C and D. B is having EF, C is having GH, D is having only one child, that is I. After E is having JK, G is having L, I is having M, and the last one K is having N. Now guys, so now we are going to search any particular node, but we are going to apply this breadth first search on whole tree diagram. Okay, using Q. So how is it possible? So for that, we are having one queue, students. Okay, so in that queue, what we are going to do, we are going to insert first node. Why? Because first node is A. Okay, after inserting first node, next step is we need to remove this node. Perfect. The process is we need to insert the node, and after inserting, next step is what? We are going to remove the node. After removing the node, what we are going to do? We are going to insert the child nodes of that parent node or that particular node. That means if you are removing node A, after removing node A, in the next step, what we are going to insert? We are going to insert the child nodes of node A. So the node A is having this particular position. So it is having B, C, D as a child node. So yes, we are going to insert B, then C, then D. Now the question will come, sir, what is the correct format of inserting the node? whether we are following B, C, D format, or we are following C, D, B, or D, B, C, or any format. Yeah. So you can use, guys, any format. Perfect. The answer is you can use any format. If you want, you can use B, C, D. If you want, you can use C, B, D. If you want, you can use D, C, B. Answer will come perfectly. Perfect. So after inserting, because we have removed this A, and after removing A, we need to insert the child nodes of this A. And what are the child nodes of node A? That is B, C, D. Perfect. After inserting B, C, D, next step we are going to remove B. Students, after removing B, we can say that the remaining nodes are C and D. But since we have removed B, so the rule is we need to insert the child nodes of B. So what are the child nodes of B? Yes, B is having E and F. So let's insert E, then F. Perfect. Very good. Now next step, remove C. We have removed the C. So the remaining nodes are D, E, F. Now insert the child nodes of C. So C is having two child nodes, that is G, H. Okay? G and H. In the next step, after inserting, next step, remove D. After removing the D, the remaining nodes are E, F, G, H. But what are we can say that now we need to enter the child node of D. So D is having only one child, is I. So insert this node from the tail, that is I. Now remove E from the head. Remaining nodes are F, G, H, I. Next step, what are the child nodes of E? So E is having J, K. Insert J, then K. Perfect. Very good, guys. Now in the next step, remove F. After removing the F, G, H, I, J, K. Now F is having no child node. Yes. So F is having no child node. Since it is not having any child node, so we are not going to insert any node in the queue. Okay. Again, in the next step, we are going to remove G. After removing G, remaining nodes are H, I, J, K. But after that, we need to check the child node of the G. So whether this G is having any child node or not. So yes, G is having child node, that is L. So insert this node in the queue. After inserting, next step will be remove again the H. So if you're removing H, the remaining nodes are I, J, K, L. And again, we are going to check whether this H is having any child node. No, guys. This H is having no child. So let's move to the next step. Remove I. After removing I, the remaining nodes are J, K, L. But this I is having M. Perfect. Because whenever if you are removing, make sure that we need to insert the child node of that node. So I ka child node is M. So we are going to insert this M in the queue. Perfect. Now again remove J. So after removing J, the next step will be K, L, M. But check whether this J is having any child node. I think no. Next step, remove K. After removing K, the remaining nodes are LM. But this K is having any child node? Yes, students, N. So we have inserted N. Now remove L. So the remaining nodes are MN, but L is having any child node? No. Again remove M, we will get N. So this M is having any child node? No. So this is the last node, that means this is the final answer. Okay. So in this way, we are using our queue. Okay. So every time we are inserting, every time we are removing. Okay. So always remember this step. This is the perfect method to use queue in a breadth first search. Okay. And the final outcome will be what is the exact final outcome of this particular method. So first of all, we have removed A. So answer will be A. Next B. So whatever nodes you have removed, write those nodes in a sequential manner. So first A, then B, then C, D, E, F, G, H, I, G, H, I, J, K, L, M, N, J, K, L, M, N. So guys, this is the answer. Okay, but for example, let's take the example. If you are searching one, because this is whole process, that means you are starting from A and you are ending with node N. But let's take the example, we are searching one node, that is, let's take the example of G. So if you are searching G, so what will happen over here? So first of all, we have removed A, then B, then C, then D, then E, then F, and then G. So G. So you are getting G over here. So we can say that your output is G, and whenever if you are removing G, that means this is your output. That means your output is matching with this G, right? Your expected output is matching with G. So if your expected output is matching with the current value of the Q, that means yes, we got the solution. Since we got the solution, what will be the answer? What will be the output over here? We are going to provide the path of that node, because the problem was to search the node G. Yes, we have searched. Perfect. After searching, what will be the output? Path. So how we are going to find the path of that node? So since the node is G, so in order to find the path of the node, we need to check what is the parent node of this G. So this G is having C as a parent node. Perfect. Now we are going to check whether this C is having any parent node or not. Yes, it is having again one parent node, that is A. Again we are going to check whether this A is having any parent node. So no, finished. So this is the output. That means we have searched node G and the path of that node is what? A, C, G. So this is the method how we are going to find the, we can say that, solution of any problem. And always remember guys, this breadth first search always runs on level wise. That means first of all we are going to visit first level, then second level, then third level, then fourth level, then next level. So how we are going to do? Yes, this is the method. Perfect. This is the method, level wise, level wise. Okay student, level wise. And after this, in a breadth first search, we are having one more concept that is called as time complexity. Time complexity. So students, what is the meaning of time complexity? Guys, in different algorithms, to check the performance of the algorithm, we are having two concepts, that is time complexity and space complexity. So that's why the time complexity of the breadth first search is order of B raised to D. Order of B raised to D, where B is the branching factor. Branching factor. And D is the depth. D is the depth. Okay. So now what do you mean by branching factor? So student, branching factor means what? The maximum number of child node. Okay. So in this particular graph, you can see A is having 3 child, but B is having 2 child, C is having 2 child, D is having 1 child, and so on. So the maximum number of child is 3. So the branching factor ki value is 3. So the value of B over here is 3. Perfect. So B is equal to 3. Since we, again depth. So guys, this is depth 0, this is depth 1, this is depth 2, this is depth 4, and the last one is depth 5. Okay. So we are searching G and we are getting this node at depth 2. So in this particular example, the value of D is 2. Okay. So if you are getting your value of, if you are getting G at, we can say, that, oh sorry, this is 0, 1, 2, and this is 3, and this is 4. I'm really sorry. Okay. So 0, 1, 2, 3. So always depth start from 0, then 1, then 2, then 3, then 4. So yes, students, we are getting this G at a depth 2. So the value of D is 2. So now what is the time complexity? Yes, B raised to D, which is what? 3 raised to 2, which is equal to 9. Okay. So maximum 9 cost, right? The maximum 9 cost we will take to search our solution. Confirm? So this is all about your breadth first search. I hope you got the things. Thank you so much, everyone.